Hello everyone, myself Jyoti Prasad from RMB Engineering College. Now I am going to discuss about the schmitt trigger uh, operation and derivation. We know the schmitt trigger is one of the regenerative circuit. Okay, normally in the BJT framed. Okay, using BJT we can make the multi vibrator. So we have three types of multi vibrator: bistable multi vibrator, astable multi vibrator, monostable multi vibrator. So here in this mid trigger, both the states are quasi states where it will where it will switch with a RC time constant. So so here no need of any extra triggering. So already we from the earlier videos we have seen that op amp can be used as an amplifier, inverting non-inverting amplifier, comparator. The major application of the op amp is one of the major application is a comparator. We can use op amp as a comparator. So comparator means it will compare the two inputs, inverting and non-inverting input, and gives the output. So here by using comparator operation we are going to make that one as schmitt trigger. So where the comparator circuit used to avoid unwanted triggering in output voltage. So we can also this one called as a regenerative comparator. So here we are using positive feedback. So because of this one the gain will be increases considerably, and the transfer characteristics become more close to ideal curves. So the ideal comparator characteristics will be shown like this. So, okay, comparator characteristics, it will be more close to these characteristics. Okay, if you see the feedback gain AVF is nothing but open loop gain by 1 plus open loop gain into beta, A by 1 plus A beta. If we are going to take AOL as open loop gain A, so A by 1 plus A beta is a closed loop gain. So here the feedback gain AVF will be infinite. If at all this one is zero, in the denominator becomes zero. Okay, so Schmitt trigger circuit gives output waveform virtually discontinuous at comparison voltage. So it will continuously switch over between the UTP and LTP. So here that's why we have called here as hysteresis backlash. So we are going to see what is the hysteresis backlash. So in his Schmitt trigger, we have the circuit shown here is a Schmitt trigger circuit using operational amplifier. The same Schmitt trigger circuit we can frame using BJTs. So that is different with this op amp. This is an active device. Using active device, nothing but op amp. Here the feedback we have taken positive feedback from output terminal 6 to pin 6 to the non-inverting input terminal through a resistive divider network. Here one more direct input, sinusoidal input, we are giving as a input for at the inverting terminal. Okay, how the load resistor is also connected at the output terminal. How the operation will happen means, here I like I said we will have two trigger threshold points: the upper triggering point, lower triggering point. See, like I said earlier diagram picture, when the input crosses the upper triggering voltage UTP. I will show you in the next picture where the sine waveform is the input. With respect to sine waveform, if the VA is greater than the one particular threshold voltage called upper threshold voltage, then the output will become zero. So likewise, we will keep on comparing with the two levels: upper triggering point and lower triggering point. These are the two predefined threshold levels. So the input voltage Vi triggers the output V naught every time it crosses certain voltages. That certain voltage is nothing but upper triggering point and lower triggering point. See here, for example, we have taken the transfer characteristics. Va is the x-axis, V naught is the y-axis. See, for example, here the Va input we are keep on giving the input. So whenever the input is greater than lower triggering point, then the output changes here. So here, say for example, UTP we have defined upper triggering point. We have defined, for example, say 10 volts. So when the input, or else 5 volts. When the input is greater than 5 volts, just the 5.1 or 5.02 like that. So input is greater than when the input is greater than the upper threshold point, then the output changes to zero, falls to zero. then the output changes like this. It will be flipped from minus vsat plus vsat to minus vsat. The same way, lower triggering point means nothing but from this side, from left to right to left side it will come whenever the voltage, input voltage is getting down, okay, coming down, and when it reaches close to lower triggering point, say 2 volts, when it reaches close to 2 volts, then the output voltage, see, the output voltage is nothing but curve. So then output voltage changes to plus vsat. So this transition will occur. So the transfer curve for vi is increasing, the transfer curve for vi is decreasing for ltp. Vi is decreasing for ltp, vi is increasing for utp. So now if you see, if you mix this one, both the graphs, so a loop will be created. So that particular loop is called hysteresis loop. Equation wise, if we want to tell the voltage difference between the upper triggering point and lower triggering point is called hysteresis width, vh. So like this loop, if we mix these two upper trigger utp and ltp curves, so we will get a loop like this. This loop will fall from right to left, and this one from left to right, increasing and decreasing. So if we want to derive the equation for the output voltage in a schmitt trigger, first case we are going to see for v not equal to plus v saturation. First present, it is in V saturation, right? In the first case, upper triggering point. So it is in the positive V saturation. So the voltage at positive terminal is VUT. So that is given by V reference into R1 by R1 plus R2. So here V reference into R1 by opposite direction, R1 by R1 plus R2 plus V saturation here output side, V saturation into R2 by R1 plus R2. Together we are going to define as upper triggering point. So whenever vi is less than utp, upper triggering point, that time output is plus v saturation. So for all this region, so whenever this condition fails, that means whenever vi exceeds upper triggering point, then the v naught will change, flip from positive saturation to negative v saturation. So this is the thing. So this is the equation for upper triggering point. The same way opposite manner happens for v not equal to minus vsat for lower triggering point. So whenever it is in lower triggering point, so see here the output will be in minus v saturation. So VLTP can be written as V reference into R1 by R1 plus R2, the same one, minus V saturation at output side into R2 by R1 plus R2. So this voltage will be hold whenever Vi is less than VLTP. Input is less than VLTP. Vi is greater than VLTP. Say the input is 3 volts, 4 volts. It is greater than the lower triggering point. So if Vi is greater than, say this VLTP is 2 volts, Vi is greater than, I mean 4, 5 volts, 4 volts, 3 volts, 2.2 volts also. So then the output is in minus Vsat. Whenever the Vi is fall down less than the VLTP. VLTP we define 2 volts, for example, say. So then 1.9 is less than, input voltage 1.9 is less than VLTP, then the output flips from minus V saturation to, from here, the minus V saturation to plus V saturation. So this will happen, and this is called lower triggering point. So the width between upper triggering, lower triggering, say 5 minus 2 is nothing but 3 volts, is with hysteresis with equation wise. See here vh is nothing but vut minus lt, nothing but v2 r2 vsat by r1 plus r2. With the value of resistance and v saturation value, we can calculate the hysteresis with or hysteresis voltage value. So because hysteresis circuit triggers at high voltage for increasing signals than for decreasing ones. So it's purely comparator operation. Greater than this one, less than this one means VA is greater than VUTP, VA is less than VLTP. So purely a comparator. VA is less than VH. Output transition from plus VSAT to minus VSAT. UTP, regarding UTP. VA is greater than VH. Output transition occur from minus VSAT to plus VSAT, LTP. So, so if on whole, if we see, Schmitt trigger is used to convert slowly varying. See, earlier we have seen in non-inverting or inverting amplifier of operation. So sine wave form, it will be converted into square wave form. So that is a normal moving sine wave with some speed. If a slowly varying input is there in any biomedical applications, the input is very slowly, then How the how the that, that, that things can be tracked means using hysteresis, I mean Smith trigger. So slowly varying input waveforms can be converted into square wave output using Smith trigger. So like we have defined, if V reference is equal to 0, so V reference equal to 0 means then VUTP LTP will defines with purely saturation voltage. So here it is not a sine wave, it is a slowly varying sine waveform. This can be converted to square waveform using Smith trigger. So if at all we are taking for sine waveform, we can also do that. Then we will get an asymmetric square waveform. I mean on time off time will be different. Okay. So thank you. This is all about Smith trigger.